select operation, project operation, and then union, set difference, set intersection, and then we also saw about Cartesian product, joining of two relations, and then Cartesian product itself. If we have if we have columns with same names, then what do we do? We saw that, and then renaming a table. And then we saw about composition of operate, like if we to using more than two operations like that, and natural join also.
Right. So can you state select operation and project operation? So what symbol do we use to represent select operation?
For select operation, we use the sigma symbol, Greek symbol, and then in that the syntax is like we the sigma, and then we specify the relation in brackets, and then we specify also a predicate it should satisfy the tuples that we finally get should satisfy the predicate condition, and then for project operation we use the pi symbol, and then we specify the relation in brackets, and then in project it's like selecting two columns like whichever attribute we want, so we specify the attribute names as a below, like we write it.
So correct, Pavitra. So the answer is correct. Thank you. Right. So Pavitra has given some input regarding the select operation and project operation. Right. So select operation, whenever I need to select a tuple or a record in a relation, I go for a select operation symbol. So it's denoted by the Greek symbol sigma. Then you have the relation. Then you have the predicate. Right. So the select operation, it's used to select tuples from a predicate. Sorry, tuples from a relation based on the predicate, right? And project operation, it's denoted by the Greek symbol pi. It is used to filter a few columns or attributes that is present in a relation, right? Then we discussed about some set operators, set union operator, set intersect operator, right? So again, I need one of you to explain it. Aravind. Selva Karthik.
Sir, yes, sir. I'm not actually sure about that.
So can you say something about the other operators, right? So we have discussed about select operator and project operator in relational
Okay, so
algebra.
select is for like retrieving the, like querying to retrieve the things. So
right, select we have discussed about it, right? Pavitra explained the select operator,
yes.
Project operator. What are the other operators? Can you explain the other operators that you are familiar?
Like in like the SQL operator, sir.
Yes.
So insert, then update.
Right. So insert, update, and all, they are SQL operators. They are not relational algebra operators.
Okay. I think union. I'm not sure about. So,
union, intersect, minus operator. I think I have shared the materials in the course materials, and you can very well look into it, and you can at least revise and tell me.
Okay, sir.
Right. Lokesh Arnagiri.
Sir?
Yeah. Can you state the set operators supported by relational algebra?
Union, difference, intersection.
Right. Union. So what's the function of union operator?
So join two sets, like combine two sets.
So it's a binary operator that is used to combine two relations.
Yes, sir.
And it gives the union of tuples that are present in both the relation.
Yes,
right?
Sir.
An intersection operation, again, it's a binary operator.
Selects the common ones.
Right. It returns the common tuples that are present in both the relation.
Yes, sir.
And minus operator.
Elements in one relation but not another.
right? So it again, it's a binary operator. It takes two relations as input, and it returns the records that are present in the first relation but are not present in the second relation.
Yes, sir.
Right? So then we discussed about the Cartesian join operation, and we discussed about natural join operation. Right? So natural join, it is used to join two tables based on the same attribute name and data types. Right? So the same attribute name may be present in both the tables. Right? So for example, the student ID, student name, age, department ID. So department ID is going to be the primary key of department table, but it's a foreign key of student table. Again, you have another relation, department ID, department name, and so on. So if I'm going to join the two tables based on the same attribute name that is present in both the table, it's known as natural join. So in natural join, it will produce a resultant table that will contain all the attributes in both the tables, but it keeps only one copy of the each of the common column. And the syntax for natural join is going to be select star from table 1, natural join table 2. Right? So here you are going to join two tables based on some common column that is present in both the relations. Whereas inner join, it joins two tables on the basis of the column which is explicitly specified using the on clause. Right? So you are going to join two tables based on an attribute name which is explicitly specified in the on clause. So the difference between natural join and inner join is that in the case of inner join, the resultant table will contain all the attributes of both the tables, including the duplicate columns also. Right? So it will contain both the original column as well as duplicate column of both the tables. Right? So here you need to explicitly specify the column on which the join operation takes place using the on clause. So the syntax is like select star from table 1, inner join table 2 on table 1 dot column name is equal to table 2 dot column name. Right? So relational algebra is going to be the foundation for relational model, data model. Right? Right. So in today's class, we'll discuss about, I think I have one topic for which I don't have the presentation. Anyway, you can look into it. So today's class will study about the classification of database management system, and then we'll start with ER model in today's class. Right. So classification of database management system. Right. So you all know database management system, and there are several criteria that is used to classify DBMS, and the first is based on the data model on which the DBMS is based. Right? So based on the data model used, you can classify a DBMS. Right? So you all know the popular data models are going to be relational data model, object relational data model, right? ER model, entity relationship model, semi-structured data model, and so on. Right? So based on the type of data model used, you can classify a database management system. So the second criteria that is used to classify a DBMS is going to be the number of users supported by the system. Right? So for example, you have a single user systems that supports only one user at a time. Right? So like your personal version of your software, single user system supports only one user at a time, whereas multi-user systems, they can support multiple users concurrently. Right? So most of the majority DBMS, it includes a multi-user system which supports multi-users concurrently. So the third criteria is going to be the number of sites on which the database is distributed. Right? So based on the presence of a location, based on the presence of a database location, it's going to be either a centralized DBMS or a distributed DBMS. So in the case of a centralized DBMS, the data is stored at a single computer site. Right? It's stored in a single computer site. It's known as a centralized database management system. Whereas a distributed DBMS can have the databases and the database software distributed over many sites connected by a computer network. right? So distributed DBMS means different databases and different DBMS software may be used in different geographical locations of a particular organization, and they are being connected by a computer network. It's known as distributed DBMS, right? So you can visualize like a railway reservation, right? Some databases, they are going to be central database management system, whereas supermarkets, right? So Reliance Retail or Future Retail, D-Mart, right? So they have they are geographically spread across different geographical locations. So here the data is spread, data is distributed. They use distributed DBMS, right? So they may use different databases and different DBMS software in different sites. It's known as distributed DBMS. So the advantage of central DBMS is that it's easy for you to make backup and recovery operations, right? So taking backup operations is quite easier if it is going to be present in a centralized database management system. And finally, based on the type of DBMS, we have homogeneous distributed DBMS or heterogeneous distributed DBMS, right? So homogeneous distributed DBMS means it uses the same type of DBMS software at multiple sites, right? So whereas heterogeneous DBMS, it is used to, it uses different types of softwares at different sites. It's known as heterogeneous distributed DBMS, right? Again, finally, a DBMS can be a general purpose where performance is the primary consideration, or it can be a special purpose DBMS that is built for specific application, right? So you have some temporal databases to store stock data, or you have some spatial databases to store geographical informations or maps, right? So DBMS can be a general purpose DBMS, or it can be a special purpose that can be built for, that is designed for a specific application, right? So these are the different criteria by which you can classify a database management system, right? So just you need to know the points, right? So the first categorization is based on the model. So based on the model, data model used for building a DBMS, you can classify it as relational model, object relational model, semi-structured model, ER model, and so on. Based on the number of users supported by a DBMS, you have a single user DBMS, right? Or you have a multi-user multi-user systems which supports multiple users to work concurrently, right? So mostly in an organization or in an academic institute, we have multi-user DBMS where you have multiple users will be able to work concurrently. Again, based on the storage, data storage, you have distributed DBMS or centralized DBMS, right? So in the case of centralized DBMS, the data is stored in a single computer site, right? So if the data is stored in a single computer site, it's known as centralized DBMS. Whereas in the case of distributed DBMS, the data will be stored in the data will be stored across many sites, and the sites may be connected by a computer network, right? So the actual database and the DBMS is distributed across many sites, and they are being connected by a computer network in the case of distributed DBMS. Then you have homogeneous distributed DBMS, which uses the same type of database type as well as the database DBMS software at different locations, right? Whereas in the case of heterogeneous DBMS, we have different types of database software and databases at different locations, right? So for example, one branch, they may be using MS Access for storing the data, whereas another branch, they may be using Postgres SQL for storing the data, right? So if you are going to use different databases and DBMS software at different locations for storing and accessing the data, it's known as heterogeneous distributed DBMS. Whereas if you are going to use the same software, same DBMS software across multiple locations, it's known as homogeneous distributed DBMS. And finally, a DBMS can be a general purpose DBMS or a special purpose DBMS, right? So when performance is a primary consideration, then we need to go for a special purpose DBMS that is built for specific application, right? So we have some temporal databases that are best suited to store time series databases, spatial databases that are best suited to store the geographical data, XML that is best suited to store semi-structured data, and so on, right? So when the performance is the primary consideration, then we need to go for this special purpose database management system, right? So in today's class, we'll study something about ER model, right? So we have two classes for ER model. One class will study about how to represent an ER model, right? The concept behind the ER model, right? So whenever you need to represent a real-time system, a banking organization or a financial institution or a university, to represent the schema design of a database, we go for this ER model. Once we represent things in ER model, the second thing is that we'll be converting an ER model into one relational format, right? So how to represent next class I will teach you how to represent a strong entity, how to represent a weak entity, how to represent a relationship set, right? How to represent entities with complex attributes, entities with multi-valued attributes, how to avoid redundancy in database design, and so on. So that will be of more useful to you, right? So we have some essay type question like will be asked to represent a real-time system, right? Maybe an university by means of an ER diagram, and then you need to convert the ER diagram into a set of relations. So this comes under the unit 9. So let me share you the, it comes under chapter 7. Let me share you the ER model, right? So in today's class, we'll study the basics of ER model.